Algebra Honors Unit 6 is on exponents and radicals, and this is the second part of the key for our exponents quiz review. So we are on the second side of this key, or sorry, the second side of this worksheet. So 15 is the top left. I should have made that smaller. We had done a bunch of scientific notation problems already, and we already had some answers for 1, 2, 3, and 4. And we are moving on and looking at solving 5 and 6. So these are our last two problems. When we're solving these division problems, because that's what a fraction is, we're going to divide our initial factors or coefficients first. So I'm going to say 2.1 divided by 2.8 on my calculator. I didn't type it in right. Is 0.75. So I'm just dividing 2.1 divided by 2.8 is 0.75 times 10 to the, I have 10 to the 7 minus 3. It's going to be 10 to the 4. So that's an answer, but here's the thing, that's not actually in scientific notation, right? So I need to move that guy over. It's going to be 7.5 times 10 to the third power, because it's smaller than 7.5, right? We had 0.75. What I'm giving you, I need to let you know that your real answer is actually smaller than that. Another way to do this is you can actually just take 0.75 times 10 to the 4, 0.75 times 10 to the 4, you go 1, 2, 3, 4. And so that is 7500, and then put that back in scientific notation. So I'm going to do a two-step. Now I'm going to go whomp, whomp, whomp. Now I see that that's 7.5 times 10 to the third power. That's usually what I do. I usually bring it to standard and then back into scientific notation because I get nervous about whether I'm adding or subtracting on that exponent. All right, let's check this guy out. So we're going to say 2 divided by 3.2. My factor is going to be 0.625 times 10 to the 6 minus negative 7 is really 6 plus 7. It's really 13, right? But this is not in scientific notation. It is math. It is a number, but I need to put it in scientific notation. So I want to say 6.25 times 10 to the 12th. Okay. This one's a little harder to bring out to your 13 decimal places, but we've just discovered that if we started out with something that was a smaller factor and we had to reduce our exponent, I know that I started out with something that was a smaller factor, and I'm going to have to reduce my exponent again. So that's it. Those are the last two problems, and I appreciate you watching.